vectors. So what is a vector? Well, a vector has two components, a magnitude and a direction. So like if that was vector v, then the vector twice v looks like that, and vector opposite of v goes in the opposite direction, same distance. Those are vectors. Okay. A position vector is one that has its initial point at the origin. So let's say we have a vector that goes from 1, 2 to 3, negative 5. From 1, 2 to 3, negative 5. There's the vector. Now, if I move that vector to a different location, it's still the same vector. So a vector doesn't have a location. It's got a magnitude and a direction. That's all it's got. Okay, let me think about what I have to do to get 1, 2 to be the origin. I guess I have to subtract 1 from the x and subtract 2 from the y. So if I subtract 1 from the x here, I get a 2, and if I subtract 2 from the y, I get a negative 7. So this vector can be written as the vector from 0, 0 to negative 7. That's called a position vector, but it's still the same vector v. Now it turns out that it's nice to have position vectors. I'm going to show you why in a minute. If we wanted to find the magnitude is just the length of the vector, and so that's just Pythagorean theorem or distance formula, square root 3 minus 1 squared plus negative 5 minus 2 squared, square root of 4 plus 49, or square root of 53. Pretty simple to find the magnitude of a vector. Now let me tell you about some things called the unit basis vectors. Unit basis vectors. There's two of them. Well, it is in R2, or two-dimensional space, there's two of them. There's three of them if you go to three-dimensional space. I is the vector that begins at the origin and ends at the point 1, 0. So I'm going to call that vector I. J is the vector that begins at the origin and ends at the point 0, 1. Those are called unit vectors because they're 1 unit long, and they're basis vectors for this reason. If I had vector v as a position vector to the point xy, let's say here's the point xy, there is vector v. If I wanted to write vector v in terms of numbers x and y, that is so simple to do. Vector I goes 1 unit this way. Now here's what I would do. I would stretch I until it met the perpendicular from the end point right there. Okay? Now how far do I have to stretch that? Well, this distance has to be x units, so x times vector I would end right there. Now vector j is 1 unit long this way. If I move vector j over here and stretch it by a factor of y, and if I add x times vector I and y times vector j, then I get vector v, because that's how you add vectors. It's that old tip-to-tail method. So vector v can be written xi bar plus yj bar. Thus, it is very simple to write a vector in terms of I and j. So that's called the unit basis vectors. The magnitude this way square root x squared plus y squared. That's how you would find the magnitude of a vector expressed in terms of I and j. That's a piece of cake. Let's suppose vector u is 2i plus j. Vector v is going to be 3i minus 2j. I want to find twice vector u minus vector v. Well, it's just a substitution. You take twice vector u, which is 2i plus j, and you subtract vector v, which is 3i minus 2j, and so I'm getting 4i plus 2j minus 3i plus 2j, and if I combine, I get I plus 4j. I bet you're thinking, boy, I hope Dave puts a lot of those on the quiz. That's pretty good stuff there. The last notion I want to talk about is a unit vector in the same direction. So if here's a vector v, how do I find a unit vector in the same direction? Well, if you just take vector v and divide it by the magnitude, that's going to be 1 unit long. So this is a unit vector in the same direction as vector v. Example. Vector v is 3i minus j. I want to find a unit vector in the same direction, so the first thing I would do is find the magnitude. Square root 3 squared plus 1 squared. You can make that a negative 1 squared if you want to. It doesn't matter. That's the square root of 10. And so, you see, if I take vector v and divide it by the magnitude of vector v, I get 3 over the square root of 10i minus 1 over the square root of 10j. That's got the same direction and has magnitude 1. Well, unbelievably, that